Hello and welcome to another video. In this video we're going to be doing minimum cost to hire K workers. And in this one you have N workers and you have two integer arrays, quality and wage, where quality is the quality of the worker and wage is the minimum wage expectation. We want to hire exactly K workers, and to hire a group of K workers we must pay them according to the following rules. Every worker must be paid at least their minimum wage expectation. And in the workers group, each worker's pay must be directly proportional to their quality. That means if a worker's quality is double that of another worker, then they must be paid twice as much as another worker. Given an integer K, return the least amount of money needed to form a paid group. So in this first example, they want to hire the 0th worker and the 2nd worker. So if you hire the 0th worker, you can pay them 70. And then basically their wage to quality ratio, this thing right here, right? This thing is 7. So that means that to hire someone else, it has to be 7 as well. So if you hire the second guy, you would have to pay them 5 times 7, which is 35. And then the second example, they want to hire 3 people. So they pay 4 to the 0th worker, which means the ratio here is 1.33. And so then to the second guy, you can pay 13.33. And then to the third guy, you can pay 13.33. So there's two kind of observations you need to make for this problem to make it significantly easier, and they're pretty hard to come up with. So I think this problem doesn't really test your algorithms. Like the algorithm part of it is pretty simple. It's just kind of like, where do I get started and what am I even looking for? So the two observations are, let's go through them. So one, at least one worker will get paid exactly what they are worth. And this is basically because, like, let's just go through this example to show you. So let's just say we hire like worker 1 and worker 2, like this first guy, with a quality of 10 and a wage of 70. And then we hire the second guy with a quality of 20 and a wage of 50. So this guy's ratio is 7 and this guy's ratio is 2.5. So basically, in order for this to match up, we have to pick the higher guy's ratio and pay that to both of them. And that's the minimum cost to hire both of them. Just pick the higher guy's ratio. Because if we say let's just pay them both at a ratio of 2.5, then the problem is you'll pay this guy 25. And that won't work because he's not going to hit his like minimum wage that he needs. So you need everyone to hit their minimum wage that they need. And the only way to do that is if you hire a bunch of workers, you need to pay them based off the biggest guy's ratio. That way, everyone will hit the biggest wage that they need. So we can even add the third guy here. So we can add Q5, W30. And this ratio is 6. So the cheapest way to hire all 3 here is to actually pay them all at a ratio of 7. And then you'd pay this guy 70. You'd pay this guy 140. You'd pay this guy 35. And you can't, like, obviously paying them all at a higher ratio, like, you can pay them a higher ratio. You can pay them like 8 or 9 or whatever. But 7's going to be the best. And if you do under 7, then what happens is the guy with the highest ratio won't get paid enough. So that's one thing you can kind of notice is if you sort by ratios, like if I have a bunch of ratios like 1, 2, 3, 4, 5, 6, and, you know, maybe I'll have a bunch of copies. If I choose to hire this guy at a ratio of 9, that means I can hire anyone from here, but I would have to hire them at a ratio of 9. And if I choose to hire, so that's like the cheapest. That's gonna be how we're gonna figure out the cheapest cost to pay. It's like we're gonna say one person is gonna get paid exactly what they're worth, and then everyone with a smaller ratio can get paid at that person's ratio. Right? And if there was more numbers, then that person would get paid exactly what they're worth and so on. Because if there was a person whose ratio was 10 and you'd paid everyone 9 times, 9, then this guy wouldn't get paid his minimum and then it would fail. So that's the first thing, is one person will get exactly what they're worth, so we can sort based on the worker to quality ratio. Yeah. And I guess this is kind of actually the second observation in one is, because of this, if we hire that person we can now hire everyone with a ratio less than or equal to this. And this is going to make it really easy to say, like, okay, well, if we hire this guy, what's the best we can pick from here? And notice now we kind of have like a data structure that we can like use. So like, let's say K is 3. Let's actually just make an array. So let's say these are the people's ratios, and let's say their qualities are just some random numbers like 5. Well, let's not give anyone a ratio of 0. So let's do this. Let's just make a random array of qualities like 5, 10, 4, 3, 2, 7, something. So, like I said, if we hire this guy and we say, okay, this guy's ratio is 5, like let's just say the index is their ratio, so 1 through 9. If this guy's ratio is 5, and the other number we store is the quality, we can figure out how much we need to pay that guy, right? Because if this guy's ratio is 5 and the quality is 2, we have to pay this guy at a 5x, so we'd pay him 10, or them. Then if this person is 3, we'd also pay them 3 times 5, and then this would be 4 times 5, 10 times 5, and so on. So if we actually store the total quality of our workers, and we know the ratio, then wage is just quality times ratio, right? Because the way we got the ratio to begin with was wage over quality. So if ratio is wage over quality, then wage is quality times ratio. So that's kind of the idea, is we can basically have an array of, the format will be sorted on this quality ratio, wage to quality ratio. And then the second thing we'll store is just the quality. Because the wage doesn't really matter, since people are going to get overpaid for the most part, right? Like, you're only paying one person what they're worth, and then if the other numbers are less than this, like you're paying this guy, you know, like 6 times, or at a ratio of 6, you're also going to pay these people at a ratio of 6, so all these people are going to get overpaid. So the only reason you need the wage is to calculate this wage to quality ratio. But then basically the problem becomes a lot simpler. So let's say K is 3. So what would happen is we'll just say, okay, let's just get the first 3 people. Their total quality here is 19. And we have to pay them all at a ratio of 4. Otherwise, this person will get underpaid. We don't want to pay them more, because if we pay them more, there's no point. But we can pay them all at a ratio of 4. So then the wage here will be, like 76? Can't count today. Okay. So if we just take the first 3 people, we pay them 76. Okay, well, that's fine. Now, what happens if we add this guy? So now, actually, I think I screwed that up. Yeah, I did screw that up. So this won't be 76. So if I take the first 3 people, you're paying them at a ratio of 3, right? Because I said this is the ratios. So this is the ratios, and this is the qualities. So if you take the first 3 people, you will pay them 19 times 3, which is 57. Yeah. Okay. So now we say, well, what if we take this guy instead? So you see, we're kind of like moving down an array, and we're saying, okay, this is the person we'll pay exactly what they're worth. And now we already have all these people, so we need like a slight modification. And the slight modification is just change the ratio, but we have the total quality, so we can use that. So here, we're saying, okay, let's add this person. And now we have to pay everyone. Now we're saying, okay, we're going to include this guy for sure. So if we include this guy for sure, then like what? And notice, if you like, even if you kick out this guy, like let's say I include this guy, but then I kick him out. Well, then I already have a previous result stored, so it doesn't even matter, right? Like so it's like I'm gonna change my quality ratio that I'm paying. But if this guy turns out to be the worst, like if this guy's quality is like 100, you know, or whatever, then I'm gonna add this guy and kick him out, and then I'll have a quality ratio of 4 with these 3 people, which is just going to be worse than my old result, so my old result will be better. So I don't really have to account for that. I don't have to keep this person. But let's say this is the case. So now that I have 4, I need to kick one out. Well, which one do I want to kick out? Well, I'm paying them all at a ratio, or I'm paying their wage is 4 times quality. So I just kick out the guy with the highest quality. So I'd kick out this guy. And now my total quality is 12. And I'm paying them all at a rate times 4. So this is 56. So now I have a better result of 56. Then we go to the next person. And now I'm paying them all 5x the quality. Now which person do I want to kick out? Biggest guy again. And now I'm paying them all 5 times the quality to ensure that this person gets paid enough. Okay, well now my total is 9, right? Yeah, 9 times 5. So I'm paying them 45. So 45 is better. Then we keep going. So obviously this is going to be worse because we're adding like the biggest number here. So essentially now we're going to add this guy, and we can demonstrate this. So we're going to add this guy, then we're going to kick this guy out. And now we're paying, we can still use this number and it's not going to affect the result because our result is already calculated from earlier. So here it would be 9 times 6, which is obviously worse, but we already have the better result, so it doesn't really matter. Then, same kind of thing. We're just going to add this guy, then kick him straight out. And then this will be 9 times 7, which is worse, so I'm not even going to do that one. Then we come over here. This will obviously be worse again, right? Because we're adding a 4, we're kicking out a 4, and we're paying more. So this is obviously going to be worse. So we can just skip that. Now we're adding the 1, we're kicking out the 4. And now our total quality here is 6. And then we're paying at a ratio of 9. So we will be paying 54, which is still worse than 45. So 45 was our best when we had these 3 people. And this is the 3 people that you'd want to hire. These 3 people that have a ratio of 3, 4, 5. And the qualities are these. So that's kind of the idea. Is we can have an array of this. We can sort it. And then we can basically have a heap that we're just adding more qualities into, kick out the biggest guy, and then we're going to pay them all at a ratio of our current person. And then the best answer is going to be what we returned. So this is definitely hard to come up with, in my opinion. So I think the hard part of this hard problem is like thinking like this. I think it's very hard. But you can come up with this a lot easier if you do a brute force, if you realize, okay, I'm paying one guy exactly what they're worth. So what you could do as like a more brute force is you just say like, I'm going to loop through all my people. I'm going to pick a person to pay exactly what they're worth. Let's say this guy. So if I pay this guy exactly what they're worth, I'm going to pay them at a ratio of, so here it would be 1/5. And then this is the ratio that I can pay everyone else. And then you recognize like, okay, well, if I try to pay this first guy at a ratio of 1/5, then I'm not going to pay them enough, right? Because their quality is 3, so I pay them 1/5 of 3, but they want 4. So I'm not going to be able to have enough. But you basically can just, for every person, you can go through and you can say like, okay, if I pay this person 1/5, is it going to at least hit their wage? And if it does, I'll add it to like my array of total comps. And then I can just take the first K total comps, like either a heap or a sort or whatever. And that would basically be like n times n log n or something. So n squared log n. And then you recognize, okay, well, the only people that, like, if I pick this person to be fairly compensated, then the only people I can pick with that person is people that have a smaller ratio. And then you can recognize I can just sort on the ratios and then I can do it. And there are a few problems like this. I haven't done one in a while, but yeah. And yeah, this thing does like work that I said that, like, even if you add this person and kick him out, you would have already calculated the previous result. So even though your ratio is too high here because you kicked this person out, it doesn't really matter because you already calculated the thing before. So this is where we're going to code. So first thing, we're going to make an array of the ratio, so the wage to quality ratio, and the quality for every person. And we're just going to make, just to keep it simple, I think we'll just make an array of doubles. So we'll just convert the quality to a double, and then we'll just use the wage and quality. So instead of having like an integer and a double or a tuple or something, we'll just do that. So we'll say, let's see, double array, and this can be like, I don't know, ratios and qualities. I'll just call it ratios. Equals new int or new double array. And so let's make a variable here. So let's just say int L equals quality length. They're both the same. Quality and wage are the same. So we'll just say this is length L and the width is 2. And let's go through our actual thing to populate it. So we'll say equals 0, I is less than L. So this will be ratios I 0. So this is going to be the actual ratio. So we need to convert one of them to a double. So we'll say double wage I. And then this will be over, so like this. Convert this to a double. And then, I don't know what takes priority, converting to a double or divide. So I'll just put it in parentheses. And then this will be quality I, like this. And then we need the other value. So we'll say ratios I1 equals. And then this is just going to be the quality I. Okay, so now we have the ratios filled out. Now we need to sort them, and we need to sort them based on the first value. So I think you can do this just like I did yesterday. So we'll say arrays sort ratios, and then you give it a function. So I believe it's like AB. Maybe I have to give it double. I don't remember. I'll find out. And then this will be double dot compare. And then this should just be the first value of each. So A0, B0. That work? Yeah. Okay, so we're sorted. Now we need to make a heap, and our heap will be a heap of, I think our heap can be a heap of integers because we can just take the quality and convert it to an integer. That'd make it easier because the qualities are always going to be integers. So yeah, so let's do that. We'll just convert back to an integer. Yeah, it seems good. Okay, so we'll say priority queue. I'll just call it heap. Just keep it simple, and this will be integer. New priority queue. And then we need to have a sorting function. So I think the default priority queue is a min priority queue, and we want a max priority queue because we want to kick out the biggest guy. So I think we can just do this. I believe. So yeah, basically, in like most sort functions, if you do a minus b, it'll be increasing, b minus a will be decreasing. Okay, now we need to go through all of our, so we need a couple more variables. We need result. We'll just make this like the biggest thing possible. So we'll say this needs to be a double, I think. Yeah, actually this needs to be a double, right? Because the ratio doesn't have to be like a whole number. Yeah, so it's like double result equals, I wonder if there's like a double max double or something. Max. I don't know if there is. Let's find out. Max value. Okay. I mean, you can just make it really big as well. And then we need to have a total, which is like our total quality. So we can say int total quality or whatever. We'll make this 0. And then, yeah, maybe we have to change this later, but this is fine. So now we need to loop through every single value in our ratios. And then add to the heap. If the heap's too big, pop from the heap. And then finally calculate the payment. Yeah, so let's do that. So let's say for double array ratio in ratios. So we need to add the quality to the heap. We also need to add it to the total. Yeah, so we can say total plus equals ratio. So the quality is at index 1 and the ratio is at index 0. We need to add it to the heap as well. So heap add ratio 1. Yeah, I don't think we even need to use the... Yeah, we don't need to use the ratio. No, we do need to use, yeah, we do need to use the ratio because that's how much everyone's getting paid. Yeah. So we do need to use the ratio, or like the first thing. Let's see what our problem is. Add. Oh yeah, so we can just convert this to an int. Okay. Yeah, so then we need to calculate, we need to say if our heap is too big, then we need to pop the biggest guy. So if this is, let's see, heap size, I think. Yes, if heap size greater than k, pop the biggest guy. So a heap, I think it's a pool. Yeah, so heap pool. And then if heap size equals k, then we need to actually calculate this new result. And so the new result is just going to be the total the total quality, which we have here. Oh, so by the way, we need to pull. We also need to get this value. So we need to say like int loss or something. Or I think we can just do this, in fact, right? Total. We just need to subtract it from the total. So if heap size is equal to k, then our result will be, I wonder if you can do a mathematics on doubles. It looks like you can. So it's going to be our old result, and then our new result is our ratio. And remember in this picture, so whatever number we're currently on, that'll be the ratio. This will not always be an integer, right? Because like you can use that like 2.5 or whatever. So, but that's what we're going to be using. So this will be ratio times the total. Okay. Well, let's see. The operator is undefined for double O. Maybe it's not ratio. It's ratio 0. That's going to be the actual ratio. Okay. Yeah, and I think that ought to do it. So now we just return result. Oh yeah, so we're trying to minimize the result, not maximize. So I think that this is like the max double is the issue. Okay. Okay, good. All right. Yeah, definitely in Java, there's a lot more to think about, like converting things from double to integers and like what type to store at, where Python you can kind of take all stuff for granted. So more to think about. Okay, so let's talk about like the runtime and all that. So first we're sorting. So first, like we're making an array with just these pairs, which is O of n. Then we're sorting it, which is already n log n. Then we are making a heap, and then for every value we're heap popping and pushing. So basically we're going to go through the whole array, which is O of n, and popping and pushing and all that stuff from the heap will be n log k. But k is always smaller or equal to n, so this just falls out. In space. So we made a new array, and this is just O of n. And then we made a heap, which is always going to be O of k. So this is just O of n. All right, so definitely a pretty hard question. I don't think we had too many hard questions recently. So honestly, I think it's pretty hard to come up with the actual logic for everything. But once you recognize those two things that I was mentioning, is one person gets paid exactly what they're worth, and for that person you can only hire people that have a small ratio, then it starts clicking on like what data structure to use. I think that's the hard part, is like going from the description to the actual like, well, how do I even do anything here? Because you can recognize that like you're overpaying a lot of people, so how is the wage even relevant and so on. Definitely not the easiest problem. But yeah, if you have any questions as always, or if I made any mistakes as always, write in the description, and I'll see you in the next one. Thanks for watching.